like the United States, where I think girls are just as desired as boys, probability of a girl being born is slightly less than the probability of a boy being born. There's theories as to why this happens, but okay. So what is the probability of this happening? Okay, this is going to be our introduction to the binomial distribution. Binomial distribution is a special case of random variable. Okay, well let's try to do this. We can try to do this with a probability tree. The first child can be a boy or it can be a girl. If the probability of a girl is 0.48, what's the probability that the child is a boy? 0.52, okay? Technically, this is a simplified worldview. It's maybe about 1 in 2,000, or not quite clearly boy or girl. But let's just say this is how it is, okay? And then for the second child, we can go boy, girl, boy, girl. Also with probabilities 0.52, 0.48, 0.52, 0.48. At this point I could ask, what's the probability of having two girls? And your answer would be 0.48 times 0.48. And if I ask, what's the probability of having one boy and one girl? There would be two ways to have one boy and one girl. The first child could be a boy and the second child could be a girl. Or the first child could be a girl and the second child could be a boy. So we would have this times this plus this times this. So maybe I'll take a moment and I'll just write this on the side. So we'll say after two children, if we're looking at number of girls, and we look at the probability, we could have 0, 1, or 2. The probability of having two girls would be 0.48 times 0.48. The probability of having one girl would be 0.52 times 0.48 plus 0.48 times 0.52. And then lastly, to have 0 girls would be 0.52 times 0.52. Is this okay? Well, you can see where I'm going. And we can do this for the third girl, and it'll look something like this. And we can go for, I mean, not the third girl, but the third child, and then the fourth child would go like this. Terrible already. And then the fifth one goes like this, right? Okay, so we have so many of these, and we don't want to do this. I certainly don't. But this would be an appropriate way to do it, if not tedious, but this would give us our answer. Alright. Well, to get, after 5 children, to have 0 girls, what would have had to have happened?
All boys.
All boys, right? It had boy, 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 boy. I have to go all the way down this thing, okay? This is the case where I have 5 boys. Are there any famous families with 5 boys? The Jackson? No. They had 6 children. No.
2 girls.
2 girls, yeah, so that didn't work. I don't know any famous families with 5 boys. Okay, so we have, so this, and for this to happen, this would be,
Baldwins.
how many Baldwins are there?
3. I think there's 4.
4?
Oh, there's 4?
Four.
It's a non-famous one. Is it non-famous?
It's like the third Manning brother, right?
Cooper
like-
Manning?
What?
Cooper Manning?
Yeah, Peyton and Eli and then the other one. Okay. Oh, it's okay. Don't feel bad. So this would have had to have happened, so 0.52 probability of a boy, and how many boys were born? 5, right? So the answer to the probability of getting 0 girls would be 0.52 raised to the 5. Let's talk about the possible ways of getting 1 girl. What would have had to have happened?
2 boys. That one.
4
There would be 4 boys and 1 girl. Okay? So in this scenario, we have 4 boys, 1 girl. Okay? But how many different ways can we have 4 boys and 1 girl? Okay? Well, I'll list them out here. It's not too terrible. The oldest child could be a girl, and then the other 4 can be boys. Or the second child can be the girl. Or the third child can be the girl. Or the 4th child can be the girl. And the 5th child could be a girl. This is the one where you'd be intimidated to date that girl, right? You have 4 older brothers to answer to. Huh?
Jimmy and Bruce have like 4 girls.
Yeah, I don't know how this works. Okay, but there's 5 ways for us to have 4 boys and 1 girl. Okay. In each of these, how many boys are there? There's 4, and the probability of each boy would be 0.52 raised to the 4th, and then there'd be 1 girl, so I'd multiply that by 0.48 to the 1. Okay, that would be the probability of this, or this, or this, or this, or this. Is that okay?
Mm-hmm.
And so if I were to combine all of these together, I would multiply this by 5. I will pause and let that sink in. And if you have questions, I just want to make sure.
Are you multiplying the 0.52 to the 0.48?
Yeah, so this is, everything being multiplied there. So 5 times 0.52 to the 4th times 0.48 to the 1.
That's the sum of the distribution.
That would be the total probability of having 1 girl. Is that okay? All right. So whatever that is, we need here, okay? What about having 2 girls? What would have to happen? I would have how many boys?
3 boys.
3 boys,
3, 4.
2 girls. Okay? And so, there might be a bunch of arrangements for, who's the oldest and who's the next and whatever. But however many arrangements we have, what is the probability for each of those arrangements? 0.52 raised to the
Here.
third times
0.48 raised to 2.
0.48 raised to the 2, and we just need to have some mystery number for how many ways can this happen. Okay, so once we figure out this number, then we have our answer here. Okay, so this number, how many ways can this happen? That is given by, I don't know, combinatorics or whatever we call it. We call this thing choose, okay? We say, we can write it a few ways. We can say 5 over 2. This is read as 5 choose 2. Alright? So you have 5 kids, quote, choose 2 of them to be girls. How many ways can this be done? So you can choose the oldest and the second oldest to be girls, you can choose the oldest and the youngest to be girls, you can choose the oldest and the third, you can choose the second child and the fourth, or whatever. How many ways can you have 5 and choose 2? That's written as this. Okay, sometimes we write it this way, 5, choose 2. This is also written like this. Okay. This is given by 5 factorial divided by 2 factorial times 3 factorial. Okay? Or anytime you see n choose j or n choose r, this is n factorial over j factorial times n minus j factorial. There's a button on your calculator, probably, that does this. There's also a table in the back that tells you these answers. Yes?
You have a formula that it says the question mark times 0.52 raised to the third power.
Yeah.
Is that formula for 3 girls?
Yeah, it's this one right here.
So if 0.52 is for the probability of boy, wouldn't it be 0.52 to the second power and 0.48 to the third power?
Oh no, he's still referring to the possibility about 2 girls.
I'm still talking about 3 boys and 2
Oh.
girls.
Okay, yeah, that makes sense.
Okay, so I got 5 choose 2, and then so I can do this. You can use factorial on your calculator. Maybe on your calculator, if you look closely, you have an NCR button. On mine, it's over the division key. On yours, it might be different. On your calculator, it might require you to hit the probability button, which brings up a menu, and then you would use the arrow keys to find something that says NCR. There's probably an NPR and an NCR, and the one you want is the NCR. And you would, on mine, you would hit 5 NCR 2, and then when you hit enter, it gives you 10. So that means there's 10 ways to have 5 children and 2 of them to be girls.
And so this is just the number that's gonna go in front of.
It's just to get this number
Right,
here.
okay. Yeah.
So when we do this, we get 10, and so the number right here that goes would be 10. Is this okay? Yes.
Can you just go over that last step again? Because on the formula says 5 over 2 factorial, 3 times 3 factorial.
Uh-huh.
You said 5 factorial over 2.
Yeah, so if you punch this out, you get 10.
So you did multiply the bottom.
I didn't, I used the calculator to give me the answer. But we could do it, okay? I would say this is the less preferred way, but 5 factorial is 5 times, not 5, but 5 times 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1, and 3 factorial is 3 times 2 times 1. Exactly.
just didn't hear you.
Oh, okay, yeah, so these all cancel, and then 5 times 4 is 20, divided by 2, and it gives me 10. Okay. But then you have a calculator that should do this. Okay? Yes.
Sorry, what did you plug in the calculator?
So on my calculator, which might be different from your calculator, I did 5, and then I have an NCR button which requires me to hit Shift Divide, but basically I do NCR, and then I type in 2. I think it looks like this. Huh? And then on your calculator, maybe you have to hit a probability button to get NCR or whatever. If you need help with your calculator, I can help you with your calculator also. But after class, after class. Is this okay? All right, so the general form, we can continue applying this concept to the other ones and come up with a general formula or equation for some probability. Okay, so let's say P is the probability of a success. Quote unquote success, because in the binomial distribution, we've arbitrarily labeled one thing as a success and the other thing as a failure, okay? Which sounds terrible to say in the application of is your child a girl or a boy. In that situation, one is considered success and the other would be considered a failure, but again, this is an arbitrary label. If we do n trials, okay? Again, trials sounds strange to say when we're talking about having children, but this is a classic case of a binomial example. So in this case, we're having 5 children. Each of those has a random probability of being a girl or a boy, and so the probability, in our case, the probability of a girl is 0.448. N is equal to 5. And then J is the number of successes that we are interested in. So perhaps we are curious, J equals 3. This is if a couple has 5 children, what is the probability they have 3 girls? Well, we've already kind of gotten to this. It is going to be n choose j. This is the number of sequences that are possible. Is the oldest one this or the youngest one, or just the number of sequences, times we want p, the number of girls, to happen j times, or the probability of a girl p, and then the probability of failure, or it not happening, 1 minus p, has to happen n minus j times. So this is the probability that y equals some particular value j. If y is a binomial variable. Binomial random variable. Yes?
Is there a different formula for each step? Like for each number of girls?
The same formula, it's just the numbers you plug in will be slightly different. Okay?
So why did we use factorial for the last one, and now we're using something
This factorial thing, the factorial thing is just expanding this. So n choose j, to get this number, We can look in the table, we can use our calculator, or we can use this factorial thing. Okay, you don't have to use the factorial thing. It's just, I'm just explaining how did I say 5 choose 2 is equal to 10? Okay, I can just tell you that 5 choose 2 is equal to 10, and that would work. But if you didn't know that 5 choose 2 equals 10, you could apply the formula or to get 10. That's all I'm saying. Okay? So if we did this for this one, I think we've already done this. We said this would be 5 choose 1, which is equal to 5 times point. I guess I did this a little bit backwards. 0.48. We want 1 girl times 0.52, and we want 4 boys. And in this case, we would have 5 choose 2. 0.48, probability of a girl happens twice. Probability of a boy happens thrice. Okay. 5 choose 3. 0.48 happens 3 times 0.52 happens 2 times. 5 choose 4. 0.48. Probability of a girl happens 4 times probability of a boy happens once. And then this would be 5 choose 5. 0.48 to the 5 times 0.52 to the 0. 0.52, anything to the 0 is 1, and then anything choose itself or anything choose 0 is also 1. 5 choose 5 is 1. There's only one way to pick all 5. Okay, that's how we would get these binomial probabilities. How do we know when a problem is a binomial problem? Okay. A binomial problem will have these key pieces. You are repeating a random trial n times. So, and every time, each trial can only have 2 outcomes. A success or a failure. Either something happened or it didn't. The child was a girl, or it wasn't. Another binomial example would be you shoot a basketball 7 times. Either the basketball goes into the basket, or it doesn't. So binomial problem, you're repeating the same thing several times, and each trial either has a success or not, okay, success or failure. And then the other key thing in a binomial is that the probability of success is p for all trials. Probability of having a girl is the same every time the child is conceived, I guess. Every time somebody shoots the basket, for it to be binomial, the probability of making the basket has to remain p. If you want to try to say that as they shoot baskets more times, they get tired and they don't shoot as well, then you no longer have a binomial situation, because what you're suggesting there is that the p changes. Okay? for it to be binomial, the probability of success for each trial has to be p. And if the situation that you're reading seems to fit this, seems like maybe it could be binomial, then see if you can pick out the n and the p, and that all of these things make sense, and then you can use the binomial. Okay. Does that work? All right. Somebody could ask, what is the mean number of girls this couple? So, if we found an infinite number of couples that decided to have 5 children, what is the mean number of girls that we would see? Well, we could do the weighted average to get the random variable, right? So we learned about random variables and finding the mean, and we would do this times this, plus this times this, plus this times this, and we would do that for all of our outcomes. That is perfectly acceptable, but we have a shortcut. Okay, so shortcuts for finding the mean. To find the mean and standard deviation for a binomial random variable. So this only works if it's binomial. Don't try to use this shortcut if it's not binomial. The mean mu, shortcut, is n times p. If you multiply all of this out and add it up, it's going to add up to n times p, always.
Can you explain what P is again?
P is the probability of a success for any one trial,
What it means success.
or whatever we've arbitrarily labeled success. So in our example, it's the probability that one child is a girl. And we said that was 0.48. If we say Chris Paul, basketball player, has a 90% free throw shooting average, meaning every time he goes to the free throw line, he's got a 90% chance of making the basket. The P in that case would be 0.9, okay? And if we say he goes to the free throw line 9 times in a game, our N in that case would be 9. So we have N is 9, P, the probability of success would be 0.9, and then the only part left would be how many free throws does he make? That would be the J. So I could say, what is the probability that he makes 8 out of the 9 free throws? Then we would do N choose J, P to the J times 1 minus P to the N minus J. This form. Okay, N choose J. So the mean shortcut mu is equal to N times P. The standard deviation sigma is equal to the square root of N times P times 1 minus P. Okay. You have a few problems in your homework dealing with the binomial distribution. And you know, be sure to just read the homework page, which describes the quiz for next week. Okay, so we'll see you guys